Okay, let's look at some examples to start to review for our final exam. So this first one says we're given an angle of 23 pi over 6. So first thing it says, let's go ahead and find the degree measure of this angle. Now remember to switch from radians to degrees. We're going to multiply by 180 over pi. So we have 23 pi over 6 times 180 over pi. Our pi's will cancel. 180 divided by 6 is 30. And so then we're doing 23 times 30, which is 690. So just a quick note where this angle is, because we'll need this for other parts of the problem. It's going to start here. There is 360. So if I go 360, that means there's about 330 left. So it is going to be right there in quadrant 4. So the next problem says, what quadrant is it in? It's in quadrant 4. A couple of things about quadrant 4. Remember, we know from our all science teachers, crazy, cosine is positive there, and thus secant is positive there. It's reciprocal identity. Everything else is negative. And it says name two angles coterminal to that. Well, remember, angles coterminal, we're going to add or subtract 360. So if I subtract 360, I will get 330. Or I could also take 23 pi over 6 and subtract 2 pi, because remember, this is the radian equivalent, and that's going to give me, this would be 11 pi over 6, because this would be 12 pi over 6. And then I can subtract 360 again if I want. I can take the 330 that I had before and subtract 360, and that would be negative 30 degrees. And so that's like this angle going right here. Or I could do 23 pi over, or I could do 11 pi over 6 and subtract another 12 pi over 6 and get negative 1 pi over 6. That's fine as well. Problems part C says, what's the reference angle? Remember, reference angle is always the angle between the x-axis and the terminal ray, an acute angle. So in this case, it is 30 degrees. But the easiest way, remember, the reference angle always matches the denominator in radians, so it's pi over 6. For the last part of this, it says, what are the 6 trigonometric function values for this angle? Several ways to do this. The one way we can do it is we can use the reference triangle. So we're looking for sine 23 pi over 6, cosine 23 pi over 6, and tangent 23 pi over 6. And I could find the other 3 just by taking the reciprocal, so nothing crazy there. Well, in quadrant 4, I know cosine is positive, everything else is negative. So sine and tangent are negative. And so now, once I know the sine, I can just use the reference angle. Sine pi over 6, cosine pi over 6, and tangent pi over 6. Now, we know pi over 6 pretty well because we have the triangle, the reference triangle for pi over 6, which is 30 degrees. We have 30, 60, 90, 1 root 3 and 2. So the sine of pi over 6 is opposite over hypotenuse. So this is going to be negative 1/2. For the cosine of pi over 6, it's adjacent over hypotenuse. So that's radical 3 over 2. And for tangent of pi over 6, it's opposite over adjacent, which is going to be negative 1 over radical 3, or negative radical 3 over 3. Now this is one way to go. The simpler way, I think, although this does review a lot of the concepts from our basic trig, the other way to go is say, all right, well, I know on the unit circle that 690 degrees is at the same spot as 330, or 11 pi over 6. Well, on my unit circle, it tells me the point radical 3 over 2, comma, negative 1/2. Check your unit circle, see if that matches what you have. So if that is my point on my unit circle, then remember, these are always ordered pairs of cosine theta, comma, sine theta. So my cosine is radical 3 over 2, like I thought. My sine is negative 1/2. And my tangent is going to be sine over cosine, so it's -1/2 over radical 3 over 2. So there's my -1 over radical 3, which is what I had here. So this just kind of reviews a lot of our basic trigonometry, a lot of our rules that we've gone through before. All right, for the second question here, let's go ahead and review graphing of trig functions. So we have h of x equals -12 cosine 3 pi x over pi over 2. Remember, the first thing we like to do with this is we like to factor that b value out, which is the number in front of the x. So I'm going to try to factor that 3 pi out. And I'll be left with x, something else, and then of course my -2. Now remember, to divide it, we're basically taking -pi over 2 and we're dividing it by 3 pi. Well, 3 pi is like 3 pi over 1, so we will multiply by the reciprocal, 1 over 3 pi. So the pi's cancel. -1 times 1 is -1, 2 times 3 is 6, so we get -1/6. If you factor that out, it'll make your life a lot easier when you're doing these problems. Now amplitude is always the absolute value of the number in front. So it's the absolute value of -12, so it's 12. And that's the distance, remember, from the midline to the top and bottom. The period is how long it takes to repeat itself. So how long it takes to go from the beginning of the period to the end. And that's always given by 2 pi over b. And b is the number we consider here. So our period in this case is 2 pi over 3 pi. So that just gives us 2/3. The phase shift is how far left and right. And that's always the value. Once you factor out your b, it's the number inside the parentheses. So in this case, it's -1/6. But remember, it's really +1/6. It's going to go right 1/6 because it's always the opposite of that sign. And this is really going to be the beginning of our period. So we start at 1/6, we go over 2/3 to find the end, so on and so forth. Finally, the vertical shift. The vertical shift is always just the number at the end. So that's -2, that would be down 2. And that's always going to be our midline. So if I wanted to sketch this, and you could be asked on the final to sketch the graph, what I would do is I would just very informally, I know it's going to start at 1/6, wherever that would be on my axis. It's going to end at 1/6 plus 2/3, which is going to be times 2 is 1 plus 4 is at 5/6. So it's going to end at 5/6. In the middle of 1/6 and 5/6 is 3/6, or 1/2. In between 1/6 and 3/6 is 2/6, or 1/3. And in between 3/6 and 5/6 is 4/6, or 2/3. So there's my axis. The midline, we said, was -2. So I'm going to put -2 here. And the amplitude was 12. So I'm going to go up 12 from -2, which will put me at 10. And I'd have to go way down to -14 to get the bottom. But remember, here is my midline. Here is my new top. Here is my new bottom. So since this is cosine and it's reflected, it was -12. Remember, the negative in front flips it. It's going to start at the bottom. Cosine usually starts at the top unless it's reflected, then it starts at the bottom. Then I go to the midline, to the top, back to the midline, to the bottom. So this would be one period of my cosine wave. Now don't forget, the nice thing about any graphing problem on a test is you can check it with your graphing calculator. So I would encourage you to do so.